our YouTube channel, and we want to show you something very interesting and amazing this lesson. So we want to talk about the coordinate system. We have four. Actually, there are various types of coordinate systems, but we want to focus on two coordinate systems, which is the Cartesian coordinate system and the cylindrical coordinate system. Cartesian coordinate system, we want to represent our Cartesian in three coordinate forms, which is x, y, and z. And in this coordinate system type, we want to focus on finding the radial vector, the velocity vector, acceleration vector, um, the gradient operator, and the Laplacian operator, and also finding an element of area and an element of velocity in a given space. So in Cartesian, as you can see, our radial vector r is represented by x in the I direction plus y in the j direction plus z in the k direction. To find the total derivative, dr is equals to d into our radial vector was x in the I direction plus y in the j direction plus z in the k direction. Meaning our radial vector or the total derivative dr will be dxi plus dyj plus dzk. From multivariate calculus,
which you can find it in our platform on our YouTube account, this platform that you're watching, Math Love.
dr is equals to dxi plus dyj plus dzk. If our radial vector r is represented in three coordinates, let's say the first coordinate is x, the second coordinate is y, the third coordinate is z, then we can go ahead and find our radial vector or the total derivative in terms of partial derivatives from multivariate calculus, whereby we know our total derivative dr is equals to partial derivative dr over dn, keeping y and z constant, dx plus dr over dy, keeping x and z constant, dy plus dr over dz, keeping x and y constant, dz. Whereby our unit vector I is equals to dr over dx, partial derivative of r over partial derivative of x. Our unit vector j is equals to partial derivative of r with respect to partial derivative of y. And our unit vector k is equals to partial derivative of r over partial derivative of y. Okay. Wow, up to there. So we can go ahead and we can jump to finding our an area element of the area. Let's draw this diagram. Hmm? Let's draw this diagram, which is gonna help us in finding this thing. So let's see how it goes. So I'm drawing a cuboid. As you can see, it's like a space, and then it has the Cartesian plane in it in 3D. We have our z direction. This one is in y direction, and then this one is in x direction. Whereby in y direction we have dy, x direction we have dx, and z direction we have dz. So an area element is given by area. Let's look at this area surface that's moving towards the x-axis or along the x-axis. It's dy dz. So the area, total area, okay, the area is the area in the x direction plus the area in the y direction plus the area in the z direction. The area in the x direction is given by, in the x direction, as you can see, it's dy dz. The area in the y direction is given by dx dz. Area in the z direction is given by dx dy. Meaning an area element, the area is given by dy dz in the I direction plus dx dz in the j direction plus dx dy in the k direction. From there, following our steps, we want to go directly into finding the volume element. The volume element is d tau is given by, you know, the formula for finding the volume. It's usually length times width times height. But in this case, we can say our length is dx, our width is dy, and then our height is dz. So this is our volume element here, and then our area element is highlighted in bold here. Yeah, so we have obtained our radial vector, area element, and volume element. We want to go to velocity vector. V is changing, r over changing g, right?
Yeah.
But d velocity is also given by d over dt into our r radial vector was x in the I direction plus y in the j direction plus z in the k direction, whereby we obtain d over dt of xi plus d over dt of y j direction over dt z in k direction. Yj is our velocity, y in the j direction, and d over dt. Zk is in the v, z is in the k direction. So velocity we can represent as velocity is equals to velocity x I direction plus velocity y in the j direction velocity z in the k direction. Let's look at acceleration now. So acceleration is given by dv over dt. But dv, we have our dv, or rather we have our velocity, which was velocity vx in the I direction, vy in the j direction, vz in the k direction. So we can say acceleration is equals to d over dt into velocity, this one, yeah, dxi over dt plus dy over dt in the j direction plus dz over dt in the k direction. Opening the bracket, we'll get d squared xi over dt squared plus d squared y over dt squared plus d squared z over dt squared goes This is in the k direction, but dx over dt is given by velocity, right? So this one will have acceleration a is equals to axi plus ayj plus az, the k direction, whereby our axi is equals to g differentiating with respect to the x velocity in the x direction, or rather in the I direction, plus, and acceleration in the y direction is given by d over d in the d over dt of velocity y in the j direction, acceleration az given by d over dt velocity vz in the k direction. Wow, so as you can see, we have done we have found the radial vector, velocity vector, acceleration vector, the tau, which is an element of volume, and the area, which is an element of area. So we want to go one by one into finding our del operator. And del operator, del or the gradient operator is given by partial derivative. Del operator is given by the I in the I direction, or rather we can start with I. Del operator is given by in the I direction d over dx over the magnitude of dr over dx, keeping our yz constant, plus jd over dy over the magnitude dr over dy, keeping our xz constant, plus kd over dz over magnitude of dr over dz, keeping our x and y constant. And you know the magnitude of partial derivative of r with respect to x will always be 1. Partial derivative of r with respect to y is 1. Partial derivative of r with respect to z will always be 1. So meaning our del operator will be id over dx plus jd over dy plus kd over dz. I have that.
So guys, if I see you have the passion in maths, if you have taken your time to view this video till this point, so I welcome you to give your advice on how we should better our tutorial so that you can understand and get the better of this video. I would like to welcome you to subscribe and give a thumbs up for this video, comment, let me get your feedback in the comment section. Thank you.
So let's find our del or the Laplace operator, which is del dot del. It's a dot product, meaning we are going to get del squared. So it over dx plus jd over dy plus kd over dz, dot product of, we're repeating the same function, id over dx plus jd over dy plus kd over dz, meaning I dot I is 1, I dot j is 0, j dot I is 0, j dot j is 1, k dot k is 1, k dot I is 0, k dot j is 0, j dot k is 0. So in this question, in this our function, we are going to get I dot I into d over dx, d over dx plus j dot j to d over dy, d over dy plus k dot k into d over dz, d over dz. I dot I is 1, meaning we are going to get d squared over dx squared plus d squared over dy squared plus d squared over dz squared. So this is our function for Laplacian operator. And I think having done all that, that is the end of our chapter for today. Uh, let's meet on the next lesson or rather the next class. And before we conclude, please kindly support this channel by subscribing. Just click the subscribe button, like, comment, share, and we're gonna do everything we can
Make you understand.
to make you understand.
Yeah, you can also share your views on the comment section where you have not understood any question, anything that you like us to do to make you understand the concepts of math. Kindly share it on the comment section. Thank you.
Thank you. Thank you, guys. Bye bye.